In this video, I'm going to show you the solved examples of physics chapter 2, motion in one dimensions. Okay, so this is part A, solved examples. Select the scalars and vectors from the following. Okay. Velocity. Velocity is a vector. Distance scalar. Acceleration is a vector. Work is a scalar. Mass is a scalar. Retardation is a vector. Right? Very easy. So why I'm doing this is because many students had doubt in similar questions. That's why if you see all the solved examples, your doubts might be cleared here and now, so your final homework can be without any doubts. Okay, express the speed of 36 km/h in meter per second. So if you want to convert 36 km/h into meters per second, so what you do is you multiply it by 5 by 18 and then it becomes 10 meter per second. Right? So if you want to convert from km/h to meter per second, multiply by 5 upon 18 and meter per second to km/h multiplied by 18 by 5. Next question. Find the distance traveled by a body in 5 minutes. Okay, we have to find the distance. Time is 5 minutes. I will convert it into seconds. So 5 multiplied by 60, that is 300 seconds. If it travels with a uniform speed of 20 meter per second, the speed is 20 meter per second. Okay, so use the formula speed is equal to distance upon time. That is 20 is equal to S by 300. So S is equal to 20 into 300, which is 6,000 meter, which is nothing but 6 kilometer. Let's go to the next question. Some people have asked me doubts in similar questions, so please understand how to do these questions. A train moving with uniform speed covers a distance of 120 meter in 2 seconds. Okay, so the distance covered is 120 meter and the time is 2 seconds. Calculate the speed of the train and the time it will take to cover 240 meter. Okay, so first we'll find the speed. Speed is equal to distance upon time. So 120 upon 2, which is basically 60 meters per second. Okay, now we have to find the time it will take to cover 240 meters. So distance is given 240 meter. Speed we know it is 60 meter per second. We have to find the time. Right? So time is equal to distance upon speed. So 240 upon 60, which is 4 seconds. Very simple. Let's go ahead. A body rises vertically up to a height of 125 meter in 5 seconds. So height, which is the displacement or distance over here, is 125 meter and the time is 5 seconds. And then comes back at the point of projection. Okay, so it rises vertically to a height of 125 meter in 5 seconds and comes back. So coming back distance will always also be 125 meter and the time will be 5 seconds for coming back also. Find the total distance traveled. Okay, so total distance is equal to 125 plus 125, which is 250 meter, right? The average speed Okay, average speed is equal to total distance upon total time. Total distance is 250 upon total time is 10, right? So average speed is 25 meter per second. 25 mean, hey, find the average speed and average velocity. See, this one is a mistake. Actually, this is the answer for the second one. And the third is, yeah, so here also there is a mistake. It should be number 3. Okay, so the number 3 is average velocity. Average velocity is nothing but total displacement upon total time. Now, as we know that the body uh, first goes up 125 meter, comes down to its same position. So the total displacement would be 0 and the total time is 10 seconds. So the average velocity is 0 meter per second. So that's the final answer for first, second and third one. Okay. A train first travels for 30 minutes with a velocity of 30 km per hour. Case 1. Case 1. A train first travels for 30 minutes. Time is 30 minutes, which is basically we have to find the total distance traveled and average velocity. See, everything is in kilometer and kilometer per hour. So let's write 30 minutes as half hour. Okay. So the velocity for the first case, T1 V1. V1 is 30 kilometer per hour. And then for 40 minutes with a velocity of 40 kilometer per hour. Case 2. And then for 40 minutes. Okay, so time 2 will be 40 minutes with a velocity of 40 kilometer per hour. Okay, so 40 minutes I'll be writing as 40 by 60, which is 2 by 3 hours. And the velocity is 40 kilometer per hour. Okay, in the same direction. Calculate the total distance traveled. For that, we have to find the individual distance S1 and S2 and average velocity. Okay, so that we'll do later. First, let's find the total distance traveled. So we know that velocity is equal to displacement upon time. So we can say that displacement is equal to velocity into time. So 30 into 1 by 2, which is 15 kilometer. And second displacement is V2 into T2, which is 40 multiplied by 2 by 3, that is 80 by 3, which is if you see let's find it out. So 80 by 3 in decimals, it would be, just a moment, 80 divided by 3, 26.67 after rounding off kilometer. Okay, therefore total distance is equal to S1 plus S2, which is 15 plus 26.67, which is 41.67 kilometer. That is the total distance traveled. Okay, next is the average velocity. So average velocity is equal to total distance upon total time. total displacement upon total time. Doesn't matter, it's the straight line in the same direction, therefore distance and displacement are the same thing. So total distance or displacement is 41.67 upon total time is, okay, we can write this in fractions so that our answer is simple. Okay, let's write it in fraction and see. So the total distance is 15 plus 80 by 3, and the total time is 1 by 2 plus 2 by 3. Okay, so this will become 45 plus 80 by 3, the whole upon 3 plus 2 by 6. This comes down, this goes up. So 45 plus 80 is 125 multiplied by 6 upon 3 multiplied by 5. So 3 twos are, and 5 25s are. So it comes out to be 50 kilometer per hour. The average velocity comes out to be 50 kilometer per hour. The answer is not matching, 35.71. Let us see if there is any mistake. So 15 threes are 45 plus 80. That is 45 plus 80 is 125. It is correct. And below that it will be 1 by 2 plus 2 by 3, which is 3 plus 2 by 6. And 3 goes down, 6 goes up. 125 into 6 upon 3 multiplied by 5. So 3 twos are 525s are. It's perfect, 50 kilometer per hour. So we have to check it in the textbook. Let's see. Question number 6. We have the textbook, so don't worry. Hey, where is the textbook? Oh yeah. No. I don't know. Where did I teach you from? Second part. Oh yeah, yes. Now I know. Okay, let me put the textbook over here. Okay, so I got my mistake. I actually did a mistake in taking LCM. So here, this should be 4. 3 plus 4, because 3 twos are 6. So here 3 will be multiplied, and here 2 will be multiplied. So it will be 4, and this will be, see, this is the mistake. So their answer is perfect. Okay, so we'll be getting 125 multiplied by 6 upon 3 multiplied by 7. So it's 250 by 7, which is 250 divided by 7, 35.71 kilometer per hour. 35.71 kilometer per hour. Right, so that is your question number 6. Okay, next, a car travels a distance of 50 kilometer with a velocity of 25 kilometer per hour, and then 60 kilometer with a velocity of 20 kilometer per hour in the same direction. Calculate the total time of journey and the average velocity of the car. Case 1. Nice questions, right? Some people have got similar doubts, so please check these questions in the method. You will understand how to solve these questions. A car travels a distance of 50 km. S1 is equal to 50 km with a velocity of 25 km per hour. V1 is equal to 25 km per hour. So we don't know the time. So let's find the time here itself. So velocity is equal to distance upon displacement upon time. So time is equal to displacement upon velocity. which is basically 50 by 25, which is 2 hours. Okay, so T1 we know now, 2 hours. Case 2. What is case 2? Then 60 kilometer with a velocity of 20 kilometer per hour. So S2 is equal to 60 kilometer with a velocity of 20 kilometer per hour. V2 is equal to 20 kilometer per hour, right? And we don't know the time. So again, time is equal to displacement upon velocity, which is equal to 60 upon 20, which is equal to 3 hours. Okay, so what we have to find? Total time of the journey. So that we know already, 2 plus 3, 5 hours. So the first answer is 5 hours. And the second we have to find is average velocity of the car. So average velocity is equal to total displacement upon total time. So total displacement in this case is 50 plus 60 upon total time is 2 plus 3. That is 110 divided by 5, which is 22 kilometer per hour. This is the average velocity. Simple. Let's go ahead. Hey, the answer seems to be wrong here. The velocity of an object increases at a constant rate from 20 meter per second. Initial velocity is 20 meter per second to 50 meter per second. Final velocity is 50 meter per second in 10 seconds. So time is 10 seconds. Find the acceleration. So we know that acceleration is equal to v minus u upon t. So acceleration is 50 minus 20 upon 10, that is 30 upon 10, that is 3 meter per second square. This is the wrong answer. The final answer is 3 meter per second square. Remember that. Okay, next. A pebble thrown vertically upward with an initial velocity of 50 meter per second. Okay, so initial velocity of the pebble is 50 meter per second. Comes to stop in 5 seconds. The final velocity becomes 0 meter per second. And this all happens in time 5 seconds. Find the retardation. Find the retardation. Okay, very easy. So retardation, which is nothing but negative acceleration, is v minus u upon t, which is 0 minus 50 upon 5, that is minus 50 upon 5, which is minus 10 meter per second square. This is the negative acceleration. Therefore, retardation, I told you that retardation does not have negative sign in front of it. It is just a number. Retardation itself means sorry, negative acceleration. 10 meter per second square is the retardation. Okay, what is this? The table below shows the distances in centimeter. Okay, traveled by objects A, B, and C during each second. Okay, which object is moving with constant speed? Object A is moving with constant speed because every second object A is covering 20 centimeter. Every second. Let me take this up. Perfect. Next question. Which object is moving with constant acceleration. Okay, so first in first second object B covered 20 centimeter. In second the object B covered um, total distance covered is 36. So during the between first and second object B covered 16 centimeter, and then it came back to 24 centimeter, and then 30. No, this is definitely not constant acceleration. Okay, what is happening over here? After every second, the distance covered by the object is increasing by 40 centimeter. So object C is moving with constant acceleration, since the rate of change of uh, uh, or you can say that body is increasing its distance covered by the same amount in same interval of time. That's why it is moving with constant acceleration. Which object is moving with irregular acceleration? Object B is moving with irregular acceleration. Hey, done. We are done with all the solved examples. So I hope that these solved examples from your textbook, they should clear your doubts to a greater extent. Now, also your concepts. Now you must be wondering, okay, from where is sir teaching this chapter? Because this is definitely not our textbook, not this one, but the regular lectures which I'm posting. So understand that these topics are, some common topics, okay, with some other books and other boards also. So CBSE board is basically having the same chapter. The first chapter in CBSE board is exactly same as your second chapter. But what I'm doing in between is I'm solving some solved examples from your textbook also. So I'm going to mix their textbook and your textbook, and you are going to have a mix of videos. But most of the topics from both the textbooks are exactly same, and that's why you'll be watching some videos from that particular textbook also. But that doesn't matter because the content is the same. Physics does not change for any board or any school or any country. It is universally the same thing, same subject. So don't be worried about what you're seeing and what you're learning. It is absolutely perfect guidance which I am providing you. Okay. So I hope you're understanding everything, and if you have any queries or doubts, please ask me. I will solve it for you. All right. So see you in the next video. Bye bye.